Right, let's get started on the next lesson. So try to finish those questions at home, okay? But if you're already finished, let's work tonight then. Okay, velocity time graphs now. So we're finished with vectors. Now we're looking on to more interesting stuff. I'm sure some of you have heard of this before, velocity time graphs. Yeah? Have you seen these graphs before? We'll have a look at them now. So let's have a look. Okay. Right. So just before we start, just to talk about some convention. So, if I have, I don't know, here. If I have a person here, we usually say if he moves this way it's plus, and if he moves this way is minus, and if he moves this way it's plus, and if he moves this way it's minus. Now that's not a rule. That's not a rule. If you really wanted to, you could change this. It's just something we usually do. It's called, called a convention. Do you know this convention? Do you know the meaning of this word in English? What would it mean, convention?
Something unified?
Not quite this. Yeah.
Not like the laws, but it's still a rule.
Agreement or usual. Yeah. So, in Ireland, it's the law that you must drive on the left. Right? This is not a convention. You can't just choose to drive on the left or the right. Okay? Whereas here, it's not a rule, but we usually choose to do this. Okay? But I think you knew that anyways. So, we have our first definition. We've mentioned this word a couple of times. We haven't actually said what it is. Does anybody know what this acceleration is, the definition?
Yeah.
But firstly, it's a vector.
The delta V divide delta T.
That's it, in words.
The rate of change. I'm poor at English, but I'm very good.
Okay, I think he's got it in words. What do you say?
Rate of change of velocity
over time, yeah. Or as you say, delta V over delta T. Acceleration is the rate of change of velocity per unit time, or as a formula, delta V over delta T. Delta V is the change in velocity, and delta T is the time elapsed. It's really hot in here, isn't it? Regina, could you open that window behind you? Just pull it down. Yeah. Up the top. Yeah, just pull the window down. Yeah. Great. And maybe the other window. Yeah. Thank you. Okay. What is the units? What are the units here?
meters per second squared.
Meters per second squared, yeah. Is meters per second. So meters per second squared. Is that okay? Yeah? Now, on to some letters. Well, for the exam, I think it's better for the exam to give the definition as a sentence. Acceleration is the rate of change of velocity per unit time. For the exam. Because if you give the definition like this, then you must explain what each part means. So it's just easier to say acceleration is the rate of change of velocity per unit time. Yeah?
Differential coefficient.
Yeah, well,
we'll call it in Chinese like this.
Well, yeah, we haven't done calculus yet, so what is it you have there? What definition do you have there?
Differential coefficient.
Ah, but that's not a sentence. Give me a sentence. What's the definition on that?
I know how to explain it in Chinese, not in English. English is poor.
Yeah, the only problem is I can only read English and not Chinese. So, in the exam, just explain it in English, and that'd be great. Okay, you got that? Now, on to some letters. So, U represents, does anybody know? Yeah, the velocity at the beginning, also called the initial velocity. In some countries, you might have used V0 or VF. But which one was it?
V0, VF.
Okay, yeah. Well, here we use, or VI and so on, yeah. Here we use U. It means the speed, the velocity at the beginning. So, what do you think V might be?
Final velocity.
Yeah, the velocity at the end, the final velocity. What does the A represent, do you think?
Acceleration.
A is acceleration. Yeah? Okay, no prizes now for what T is. Time. And the last one is S. What does that represent? Displacement. Yeah. Also called the position. Right, so what I'd like you to write down is U, you could say U, initial velocity, V, final velocity, A, acceleration, T, time, S, displacement. That's fine.
So, and U and V are instantaneous velocities.
Yeah.
We all should use U for the beginning, the
Yeah.
velocity in test.
Yeah, don't use V0. Makes me sad. Use U.
U makes me remember we use the U of the head of the age in map.
Huh?
Age in map. We use U of the head of the age in map. Map is a logarithm in computer science.
Oh! Which algorithm?
Map?
Map reduce?
No, map.
Just map?
Just map.
I don't know map. I know map reduce.
Many dots, and we connect them with age, and every age is a vector, and we have head, we have tail, we have the weight, and we can.
Okay.
There are a lot of algorithms about map in computer science.
And where's the U?
What?
What's the U?
U is the head of the age.
Oh, the head.
G.
Ah, yeah, okay. Okay. Interesting. I don't know this though. I only know map reduce. I don't know map. No. Okay, you got this?
Do you know the shortest pass?
I used to, but I don't know it anymore.
It's a
You asked me 10 years ago. I could say yes. Not today though.
Nowadays, the Chinese scientists invent a new algorithm for short pass. It's called SPFA, but it's forbidden in the international race.
Oh, interesting. Forbidden Chinese secrets. Exciting.
It can
Faster,
it
yeah.
can solve the
Okay.
problem in ON, but the slowly it will reach the ONM.
Okay, but it's banned, which makes it more
And because
exciting.
you need to decide the special data for testing this algorithm. And
Okay, interesting.
if you don't design the special data, it can cheat. It almost like a cheat on the shortest path problem.
Interesting. Well, speaking of shortest path, do we know who this person is?
So
Very good. Why is he famous?
Fastest 100-meter sprinter.
Yeah. So I just want to use this example just to make sure we have a picture of what U, V, A, T, and S are. So for this race, what's the U for this race? U. 0. Why is it 0?
Stationary.
Yeah, they begin the race at rest. The U is 0 meters per second. Right? Roughly, what's the V?
10 point something.
Yeah, it'll be 10 point something meters per second, roughly. Because what's the S? 100 meters, yeah. And what's the T? It's a little bit less than 10 seconds, 9.6 or something, isn't it? Yeah. The A, I don't know what the A is. It's acceleration. It'd probably be pretty big because they start at rest and very quickly they get to 11 meters per second. And maybe this only takes them, I don't know, 3 or 4 seconds. I'm not sure. Something like this. So this is a good example of the UVATS. Remember, velocity can be positive or negative. What would a negative velocity mean?
Other direction.
Which way is it moving? Backwards. Yeah. But speed is only positive. Yeah. Also, displacement can be positive or negative. What would be the meaning of a negative displacement? It's behind you. Yeah. But distance can only be positive. Okay? Do not confuse these, please. Don't confuse them. Thank you. Okay. So what we're looking at here is what's called the velocity time graph. And velocity time graphs are really nice graphs for telling you the movement of something. Okay? It's quite simple. On the x-axis you put the time, and on the y-axis you put the velocity. So let's imagine this is a car. What is happening here? What's the car doing? It starts at rest. And its acceleration is big or small? Small. It's accelerating slowly. Maybe because it's driving on a small road. But then what happens here? What does the driver do? Describe what the driver does. It shifts gear, perhaps, yeah? Or yes, I would think so too. Enters a highway and puts his foot down. Yeah, puts the foot down to go faster. But what is happening here? Cruise control, perhaps, yeah. Reaches a speed limit on the highway, perhaps. Yeah? Now, rapid deceleration. What's happened here? Brakes. Accident ahead, possibly. And what's happened here? Stopped. Yeah. And then here? Attempting to reverse out of the motorway to exit or something like this. And then this one here is driving backwards at a constant speed. Yeah? So what's nice about this graph is you kind of get the whole picture of what's happening. Yeah? Accelerates slowly, accelerates quickly, steady speed, rapid deceleration, stopped, decelerating backwards, decelerating backwards, and then traveling at a constant speed backwards. Why is this smaller than this? Well, most cars can't go that fast backwards. This is lower down than this is higher up.
It makes me remind
Yeah.
RPM and the horsepower.
RPM for the car, yeah, and horsepower, yeah. So like something has clearly changed at this moment. Like you said, gear has shifted, or they put their foot down, or something has happened here, yeah. Cruise control, yeah. So I would like you to copy this in your book because there's lots of nice vocabulary here. Do you know the meaning here of rapid deceleration?
Yeah.
Rapid? Very fast, yeah. Or down as well. Yeah. Okay, I think if you can draw this, that would be great. You can add that to your notebook. Can you see it okay?
Yeah.
It's-
I just made the map 1,000 times 2 years ago.
2 years ago.
Yeah. We studied in grade 1 in senior high school in China. Not only the real.
How old is grade 1? How old are you in grade 1?
In senior school, grade 1.
Yeah, what age is that?
15.
15, 16, okay. Yeah, okay. Okay, can you copy this in your notebook?
Yes.
Make it beautiful. the video, yeah.
Oh, because it's difficult to see.
You can't see?
The word is too small.
Is it?
Yeah.
Really?
It's quite small.
If you can't see, then you can watch the video and copy it. Just leave some space for it, yeah.
I think so.
Be easier, will it? Yeah. Guys, if you can't see the words, you can add them in later from the video. Maybe that would be better to do. It'll give you a chance to subscribe to my channel.
Yes, we're already.
So, thank you. Subscribe and click the bell icon for notifications. Yeah.
Like, subscribe.
You subscribed, yeah?
Yeah.
Did you leave me any spam comments yet? No?
No, but I leave every likes.
You did like?
Yeah.
Nice, okay. But no spam comments yet? No, not yet. Later, maybe. Alright. I think, guys, it might be easier to get the names from the video later. Or can you see this okay? You can see okay. Alright. These guys can't see, okay?
Did it mark the area means on this map?
We'll talk about that later, yeah, the area, yeah. Right now we're just introducing the idea. Some people are able to write the names down, some people can't. Too small for you to see?
Yeah.
Yeah, okay. You know what the problem is? Too many video games,
Yeah.
I think is the problem.
Yeah, play like
because
4,000.
in China, we'll study for a long time every day, and almost every Chinese science student have
Bad eyesight.
science.
It's a problem with Chinese education, is it?
Yes.
How was the video game? What was it? Call of Duty, wasn't it? You were very excited about it. Was it good or was it bad?
Before I come to Ireland, I have never played Call of Duty
Oh, I
for a
know.
whole year.
And I remember last weekend you were so excited.
Yes.
So, how was it?
The Modern Warfare is very good, but still some small problem.
That means it was no good. That means it was no good and you didn't like it.
Too much
Yeah,
hamper.
okay. How much did you pay for it?
$60.
$60, okay. Maybe the next one will be better.
Generally, it's a good game.
It's okay?
Better than Back Ops.
Is it $60 okay?
$60.
I think it's fine because
It's
the
fine price?
The most common word is still also $60 when it's purchased.
Okay. I only ever buy games on Steam when they're on sale. Yeah.
PlayStation?
PC. Steam. You know?
Yeah, I mean, I played 4,000 hours on Dota 2.
Yeah, everybody loves that game.
Yeah.
Yeah, very, very popular. Very popular, isn't it? Yeah. Yeah. I like to play the Lego games. I like the Lego games. Lego Batman. These are great. They're great, aren't they?
Yeah.
So much fun. My favourite one is, I think, Lego Batman 2. It's great.
Which game?
You don't know it. It's okay.
Look,
You know this game.
yeah.
You play it?
I have seen my friend.
Yeah. It's good, isn't it? Yes. You play this one? No Lego games? Oh, that's a shame. Alright. We'll continue now. If you didn't get this finished, you have to watch the video. Okay? Right. So, here's a small question I want you to do. I want you to read this story and draw the graph. Okay? Read the story and draw the graph. Do you all know this word maintains? Yeah. Can you draw it? Do you know the shape? You got that drawn? Can I see? Can you turn it? Let's see. Yeah, good, good. Did you write in time and velocity? Yeah. You got it drawn?
Yeah.
Not yet. Oh, I don't know about that. Let me see that one. Okay, maybe we should draw it. A car starts from rest. Okay, so let's sketch this out. That's time. That's velocity in meters per second. And this is the time axis in seconds. Okay, it starts at rest. It slowly accelerates to 20 over 10 seconds. So that's 10, and that's 20. It maintains this speed for 5 seconds. Then, suddenly decelerates to rest in 4 seconds. So this is what you should have. I hope you got that. Yeah? That is a tiny graph. You drew this huge axis and a tiny graph in it. Yeah. It's not quite in the right proportion. Okay, continue. Yeah. Right. So, you all know this triangle from school. Or maybe some people actually haven't seen this before. I'll draw it here for you. You can copy it down. Distance, speed, time. And this triangle is great because it gives you 3 formulas. You can say distance is speed multiplied by time. Distance, well actually I have it drawn in here. If you want to know the distance, look, if you want to know the distance, you say it's speed multiplied time. If you want to know the time, you say it's distance over speed. And if you want to know the speed, you say it's distance over time. This triangle is very useful. There's only one problem with it though, for the moment. It only works when the velocity is not changing. Because you see here, speed can only be one number. You can't put in 2 numbers. You know, if I said the speed is 3 meters per second and then it's 4 meters per second, that's a problem. So the speed has to be constant, not changing. Okay. Does the distance change? No, not really. Like it's a total distance from A to B, one number. Does the time change? Or is there 2 times? No. There's 1 time from A to B. But the speed could change. The speed could be different here and different here. So this triangle only works if the speed is one number, a constant. Okay? So, you don't need to draw it 3 times. Can you at least draw it once, please? I call this Dad's silly triangle, distance, speed, time. That's what it's called here. Yeah, I suppose you could call it the distance, speed, time triangle, but that's not exciting. You drew one triangle? Yeah? Just the one triangle's enough. Continue? Yeah? You just need to draw one triangle. Okay, let's continue. Okay. Right. Here's a small question for you to do using the triangle. A boy walks 2 kilometers to school every morning. It takes him 30 minutes to walk his journey. What's his average walking speed? Okay, what's the distance? 2. What's the time? Yeah, but if we put it in hours, what would it be? 0.5 hours. So what's his speed? Speed is distance over time. Yeah? 2 over 0.5, what's that? Yeah, try again. 4. 4 kilometers per hour is his speed. Yeah? It's okay? You may be thinking that the velocity time graph can tell us velocity at a given time. That is true. However, it can tell us much, much more. Let's see. So, this is what you were saying earlier about the area.
It's the distance.
It's the distance, yeah. Here's time. And here's velocity. And let's say, here's the graph you did earlier as an example, okay? There is a meaning to the area here. And as you said, and some of you might know this area represents displacement, or distance rather. But if everything is positive, it's okay.
And the AT graph, the area represents the velocity.
Yeah, no, but just for this graph, let's just stick with this one for the moment. Does anybody, well, the slope, do you know this word from maths class? Slope? Gradient, yeah. What does the gradient represent here? Acceleration. Now, why is that? Well, I'll give you a little hint, okay? What's the unit on this axis? If it's time. Seconds. And what's the unit on this axis? Meters per second. So what is the unit of the area here? It's meters per second times seconds. What does that give you? No, just meters. Which is good, because what's the unit for S? Meters. Okay. Now let's look at the gradient. So if I was to call this here V, or no, actually, you know what? You could, yeah, I don't know if you've done this with Joan. Joan's teaching you maths. The gradient is rise over run. Have you seen that? No. Rise means this, and run means this. What's this unit? If it's this length? Meters per second. And what's this unit? Seconds. So what does this become? Which it should be if it's apparently representing acceleration. Okay? So look, to summarize, U is the height at the beginning. V is the height at the end. A is the gradient or the slope. Okay? T is obviously on the base. And lastly, the S is represented by the area. Okay? So I think at the very least you should write down what the A and the S, because I think you know the other ones. I just really care that you write down the A and the S. got that? Yeah? Let's have a look at an example.
Can you go?
Yeah?
Yeah, thank you.
What are you writing down?
Yes.
Okay. I have enough time to do one example. Let's see. And I have two examples. Which one will I do? This one's boring. This one's exciting. Let's do this one. Right. An object can accelerate at 5 and decelerate at 6. If the car accelerates from rest, I guess it's the car now. I didn't say it was a car at the start. It's a car. If the car can accelerate from rest and then decelerates to rest in 22 seconds, how far has the car travelled, that should say. So I'll draw the graph for you. Here's the car, what it does. Come on. There's time. There's velocity. It can accelerate at 5 and 6, and it's 22-second journey. So what it does is accelerates up at 6 meters per second squared, and then straight away it hits the brakes and comes back down with 5 meters per second squared. And because it's deceleration, if you want, you can write the minus in here. You don't have to write it in if you just remember that it's going down. Okay, so I'll just put brackets around that. And the time is 22 seconds here, from here to here. So I want to know how far has the car travelled. So what do I need to calculate here?
We need the x for
The area, and you might need the time here. Yeah?
The x for the time and the 6 mute x.
You're going to call this x, yeah?
5 mute 22
5 what?
X.
5
Multiply.
multiplied by, okay, yeah,
Multiply
great.
by 22 minus x.
Okay, got you. That should do it. We want to get the total distance here, but we can't do that straight away, because the problem is, although we know the base, what do we not know? We don't know the height. Okay. So what we could do, there's a couple of ways to do it. What I would like to do is, here, you could call this one T1 and this one here T2.
T2 is the 22.
I know, I mean, it's, yeah, well, okay, fine. Just leave me to do it my way, please. T1 plus T2 equals 22. That's what I like to say. Okay. Are you happy with that? Yeah, okay, that's fine. Right. Now, I'm going to call this height here V. Okay? So you can say V over T1. What should that equal? V over T1. What should that equal? 6. Okay? And V over T2. V over T2. What should that equal? Should equal 5. As long as I use positives here. Yeah? Is that okay? Now, what I could do next is take these two and combine them with this to get an answer. So we need to think about what way to combine them. What would be nice? What would be nice? What would be nice? V equals 6T1 or T1 equals V over 6? Yeah, you could say T1 equals V over 6, T2 equals V over 5. T1 plus T2 should equal 22. So you can get the V from this, can't you? 1/6 plus 1/5. 1/6 is a number and 1/5 is a number, and together it's a number. What number is it? 1/6 plus 1/5. Don't make me do it in my head. I'm tired. I'm thinking about my lunch. What is it? 1/6 and 1/5? What is it? Well, I know it's 30 down here. What's it on top? 5 plus... Oh, no, I'm tired. 11, is it? I'll trust you. 11 over 30V equals 22. So that means V is 60? 60 meters per second. Is that right? Yeah? Okay, great. We're finished. We have the answer because I want the area of this triangle now. So the area is half what? By what? A half, come on, you know this. A half 22 multiplied by 60. Yeah. So what's that? It's 11 multiplied 60. What's that? 660 meters. Is it?
Yes.
Yeah? Don't make me doubt. Is it right? Yeah. Now that's a hard example. Usually the examples they give you are kind of boring. Really boring. Like, you know, they give you something like this. But they give you all the numbers. So it's quite boring then. You know, they say, oh, this is 2, this is 3, this is 1, and this is 5. And then you go, and add them up. You know, very, very boring. I wanted to do an interesting example. This is an interesting example. I think this example is maybe more difficult than what's in the exam. But when you do the homework questions, you'll see how difficult they are. I think, just before you go actually, can we just have a quick look at one of the questions? We can just open this up and just have a look at what they're like. Can you open them up just to, or well, I can open it here too. Server 276. Ah. Let's have a look. Now, okay, so have a look here. Look at this boring question for the first one here. So boring. What do I want? I want the V here. Oh, not as nice as that. No. You know the total distance is 200. Right, guys, oh wait, please. I know you're hungry for lunch too. I'm hungry for lunch. Just look at how we would start this one. What's the total distance here? It says it's 200. Okay? And they want to get the V. Okay? So what I would say is this. A half 4 multiply V. What does that give me? It gives me this area, doesn't it? Plus 20 multiplied by V. What should that equal?
200.
Very good. It should equal 200. Can you get the V?
Yes.
Of course you can. It's stupidly easy. Here you go. And then you just divide by 22 and you're finished. That's the first question. That's it. That's all they want. You see, it's very simple, this one is, okay? And there's some, they get a little bit harder, but, you know, the number 6, 7 are kind of harder. There's only 8 questions there. When's our next physics class? Later in the week or tomorrow already? So we have no class then on Thursday. Wait, what day is today? Tuesday, isn't it? So we have class Monday, Tuesday, Wednesday? No class on Thursday and Friday. So look, guys, what you could do if you want. Listen. What you could do, because you have no class Thursday, Friday, you don't have to do all 8 tonight. What I recommend you do is do 1, 2, 3, 4 tonight, and then you can finish the others over the rest of the week. Okay, so just please do at least 4 tonight of this. All right? All right. Now we can go for lunch.
So teacher, we don't need to join to the academic scale class.
Not this week. That starts next week.
Oh, so we
Yeah.
finish next semester.
Are you finished? Oh, nice.